welcome back. This is the final transformation that we go over, which is changing the period. In previous lessons, we talked quite a bit about these graphs. We had the basic parent graphs, which we should know the shapes. We have changed the amplitude, which is vertical stretch, vertical dilations. We have vertical shifts. We have horizontal or phase shifts. And finally, we want to change the period. Because before, we've been treating everything with a period of 2 pi. So we are changing the period. And this changing the period, we want to either stretch it out or compress it. But it's still keeping, this is kind of a bad example. But let's say we're stretching it out like this, or we can also kind of compress it like this. So it's still keeping the same max and min, still keeping the same amplitude that it counts at a race. And now how do we go about this? This is actually horizontal dilation, horizontal stretch. And back when we first did it, that is, we're just multiplying your x in your function. You multiply it by a set value, and that controls how much is stretching or compressing. So the final formula that we have for our function with all the transformations looks like this. A times trig of b theta minus h plus k. We will talk about why this is the case in the second part of this lesson. But the first part, we just want to see how this looks. So let's get our graph back. Let's chop off all this stuff and put a b right here. Add a slider for b. Now, I only think for a second before I slide this. As b increases, the value inside, think about how it changes. Does it move faster or slower? And as a result, would that cause it to compress or stretch? So take a second, think about it. You can try plugging in values that you think might work. So pretend that b is 2. What will happen if you have not sine of theta, but sine of 2 theta? What will happen? And then if you think about it that way, think the reverse as well. If I divide by 2, if I do half theta, what will happen? Let's think. So what we actually need is like the inside of here, once the inside of this reaches 2 pi, one full cycle is done. Once it reaches 2 pi, one cycle is done. So if b increases, if b becomes 2, I'm multiplying the inside by 2. So theta only needs to become pi to complete one full cycle. So if b is greater than 1, it actually compresses. Because once, instead of needing theta to go all the way to 2 pi, it just needs to get to pi and I finish one cycle. So let's see this. As I increase it to 2, we see that one full cycle finishes at pi. On the other hand, as I stretch it out, let's say to 1/2, at 2 pi, I'm only gone half the amount, because at 2 pi, the inside is actually still just pi. So as b decreases, b is from 0 to 1, it stretches out. And we see all the way over here, it's at 4 pi for one full cycle. So that's how b changes my graph. Let's work through it. Let's graph 1 together. So we already kind of seen it, but let's just graph cosine of 2 theta. So my amplitude is, actually let's make it like 2 cos 2 theta. Or 3, so it's like it's not too confusing to have 2 2's. My amplitude is 3. So my y-step is 3. But my period, we talked about it, oh, like 2 over here, it'll compress it down by a factor of 2. But that is a weird thing to try to memorize and try to keep track of. So instead, what we found out is my basic period is 2 pi. And my default value for b is 1. I kind of gave a hint, but like we want to see how is this 1 being applied to this 2 pi to keep it as 2 pi? And there's two options, either multiply by 1 or divide it by 1. And now let's look at, instead now I have 2. We talked before, if there's a 2 here, that means that inside is being doubled. So it actually gets there faster. So if it gets there faster, my period will decrease. It will shorten. So what we actually do is your period formula is now 2 pi over b. This is my period. 2 pi over b. We plug it in. You have 2 pi. B is whatever's multiplying theta right here. 2 pi over 2 to give me just pi. So my period is pi. And then I also need my x step. X step is period over 4. So pi over 4 is my x step. And then I also need my my shifts. I look over here, I see that there's no h, there's no k, so there's none. Let's graph this. We start with a basic point. We start with our starting point from parent function. Cosine starts at 1. Then we do an amplitude. I go up to 3. And my shifts. That's it. We don't talk about a period at the very beginning. We're just done. So I start at 0, 3. And then we just keep on going with our general shape and do our x and y steps. Where we start here, we end here, we cut it like this. So I go down, I go forward, pi over 4, and I go down 3 to over here. Pi over 4, 0. Then I go forward another pi over 4, and I go down 3 to get 2 pi over 4, or just pi over 2. I go forward another pi over 4, and then I go up 3 this time to get 3 pi over 4, 0. And finally, I go forward one more pi over 4 and go up 3 to get pi, 3. We draw a line, and here we are. This might take me a bit to pull up, but also I did make a little diagram that might help with this. Let me pause. I'll be right back. A quick little warning. This will be very bright, but here's this little drawing that I made with just the dilations and compressions, no shifts. So I have a times cosine b theta, where a is my amplitude and b is affecting my period. Amplitude is absolute value of a. Your y step is your amplitude. Your period is your 2 pi over b. Your x step is your period divided by 4. I'll see if I can link this to the bottom of the video, the description. If not, I'll just put it on Canvas somewhere. Cosine, we see that we start. This is the darker lines are my axes. We start at positive amplitude because there's no shift. And then I go forward an x step, or period over 4. I go down a y step to end up at 1 x step, comma 0. Then I go forward another x step, go down another y step, to get 2 x steps and negative amplitude. Because we see right here, we're subtracting amplitude. Amplitude minus amplitude equals 0. 0 minus amplitude equals negative amplitude. Then I'm going to add to it. So negative amplitude plus amplitude gives me 0. I add, so I have 3 x steps now. Then I go forward one more. I have 4 x steps, or my period. I have my full period and a positive amplitude as my y value. This, I think, helps me visualize my x and y steps a bit more. How it's being divided up pretty cleanly into x steps and y steps. Once again, I'll try to post this somewhere, and hopefully this is helpful. Now, let's do one problem with everything all together. So give me a number. Okay. So the numbers that we'll use will be 4 sine we'll do theta over 2. I do theta over 3 minus minus 1/6. That's kind of weird. My handwriting's not good. 1/6 plus minus 2. A lot going on here, but let's slowly break it down. And this is actually one more trick that we want to see for this graph. If you take a quick look, this doesn't look like this. The key thing, fortunately for us, it is circled here, or underlined here, boxed here. But my insides don't look the same. The inside of my trig function looks slightly different, where this is b, and parentheses, theta minus h. This, I just have two things. Theta is not by itself, and I have h. We can't just go about treat this 1/3 as theta, as b, and this minus 1/6 as h. What we have to do is we need to convert it like that. So theta needs to be by itself. So I want parentheses theta. What did I take out of theta here? What I took out was the divide by 3, or the 1/3. I took out the 1/3. So what I must do as well is I must divide the 1/6 by 1/3. Or 1/6 times 3 over 1. That gives me 1/2. Theta minus 1/2. Minus 2 sine 4. So this is equivalent, but we're just forcing a GCF. We're forcefully taking out the 1/3. It might work out cleanly like this, it might not work out cleanly, but you want this like this. So that gives me these values. A equals 4, B equals 1/3, H equals 1/2, K equals -2. You don't need to do this, but I'm just showing us that these values, I have all these values. What you do need to do is actually your amplitude, or your y step, in this case, is 4. Your period is 2 pi over b. So you have 2 pi over 1/3. And this, once again, if you have trouble with adding multiplying fractions, feel free to write it out. 2 divided by 1/3 is 2 times 3 over 1, or 6 pi. So period equals 6 pi. And then my x step is my period divided by 4. So 6 pi divided by 4 gives me 3 pi over 2. And lastly, my shifts. My shifts, it is to the right, 1/2, 1/2 to the right, which I realize now is not good. So I'm going to make an executive decision to actually change this. So instead of being 1/2 to the right, I'm going to go back, and this might anger you guys, but it will make it much easier to graph. I'm going to change to pi over 6. So instead of what we have over here, if it lets me erase it, if I have pi over 6 over here, pi over 6 divided by 1/3 will be pi over 2. So theta minus pi over 2. H equals pi over 2. So it'll be pi over 2 to the right. And then k, since it's -2, it's 2 down, 2 units down. And this is all the work that I do before I start graph. Before I even make my axes, I have all this here. I have my equation that's given to me. I convert it into a nicer form that gives me all these values. I find my amplitude or my y-step, my period, my x-step, and my shifts. That is all the setup you need to do before making your axes. And I'm going to try to do this in a way that I can still see it. Because right now, I don't need my original equation. Actually, my equation's here, but I don't really need this anymore. I just need this little section right here. So I'm going to start, make my axes, and I see start position. Start position, where does sine start? Sine starts at 0, 0. Then do amplitude. 4 times 0 is 0. And then I do my shifts. I do 2 down, 1, 2 down, and pi over 2 to the right. How much is pi over 2? I see my period is 6 pi. My x-step is 3 pi over 2. So my x-step is triple my shift. So I don't need to move it that much. I move it this much. So right here will be pi over 2 negative 2. That's my start. To hide this once more, and actually, let's use this. We'll see how this looks. My y that I don't like that at all. My y step is 4. My x step is 3 pi over 2. So I go forward 3 pi over 2. So 3 pi over 2 plus pi over 2 gives me 4 pi over 2, or 2 pi. So let's make it right here. Let's say that's 2 pi. And then I want to go up 4. So negative 2 plus 4 gives me positive 2. So over here, 2 pi at 2. And let's actually just show the work as well. So what we're doing right here was pi over 2 plus my x step, 3 pi over 2, to give me 4 pi over 2, which is 2 pi. And then we want to continue on. 4 pi over 2, which is this, plus 3 pi over 2, gives me 7 pi over 2. So that's my next location. And I actually want to go back down. So I went, sine goes up, then it goes back down. So 2 minus 4 is back down here to negative 2. 7 pi over 2, negative 2. And the sine continues going downwards. But first we find the x. So 7 pi over 2 plus 3 pi over 2 gives me 10 pi over 2, or 5 pi. So keep on going. 5 pi all the way down to here. 5 pi negative 6. And then lastly, I'm kind of running out of space, but 10 pi over 2 plus 3 pi over 2 gives me 13 pi over 2. So this last one is 13 pi over 2, negative 2. I connect my dots as best I can, but a bit better than that. Let's put in more effort. That's close enough. Because we see it looks just like my sine curve, but it's much bigger, much more spread out, because my amplitude is 4, my period is 6 pi, much, much bigger. You see all my 5 points are clearly labeled. It is a nice smooth curve that touches or gets really close to every single point. And that is what you need for full credit for a graph. You might also be asked for some key values like this. What's your amplitude? What's your period? But here we are. So this is graphing fully. At this point, we should understand everything that we need to know of how to graph from an equation. What is up next is using this knowledge a bit more flexibly. So we're going to start talking about word problems. The next question will be some views on how I like to approach word problems, especially for math, and especially for this concept. And then applying it, going from graph to equation, going from graph to properties. So it's working backwards, working in different ways, working in different directions. But conceptually, we understand everything that we need to know. All right, good luck studying, and please let me know if you have any questions.